Hello class, we're about to start section 6.1, Algebraic Expressions and Formulas. The objectives: to evaluate algebraic expressions, use mathematical models, understand the vocabulary of algebraic expressions, and to simplify algebraic expressions. Now, algebraic expressions. The main difference between arithmetic and algebra is the use of variables in algebra. Algebra uses letters, called variables, such as x and y, to represent numbers. An algebraic expression is a combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as powers or roots. Examples of algebraic expressions are x plus 6, x squared minus 6, 6x, and the square root of x plus 7. Evaluating algebraic expressions. Evaluating an algebraic expression means finding the value of the expression for a given value of the variable. In other words, we replace or substitute the variable with a given number. Many algebraic expressions contain more than one operation. Evaluating an algebraic expression correctly involves carefully applying the order of operations agreement. Order of operations agreement. We must perform operations within the innermost parentheses and work outward. If the algebraic expression involves a fraction, treat the numerator and the denominator as if they were each enclosed in parentheses. Evaluate all exponential expressions. Perform multiplications and division as they occur, working from left to right, and perform additions and subtractions as they occur, working from left to right. Now we have some examples here. It says evaluate 3x plus 7 if x equals 11. So that means we must take this 11 and substitute it in for x. So we will replace x with 11. So this 3x will become 3 times 11 because this is 3 times x plus 7. 3 times 11, we know we do multiplication before addition. That will give us 33 plus 7, or our final answer, which will be 40. Now we come to the second example. It says evaluate 2x squared minus 7x if x equals negative 3. So we want to take this negative 3, and wherever x appears, we will substitute in negative 3 for the x values. Now remember, this x is multiplied to this 2, but it's squared, and this x is multiplied to the 7. So when we come down here, when we substitute in our negative 3 for x, if you notice, we put it in a parenthesis. This to signify that we substituted. So now we have 2 times negative 3 to the second power minus 7 times negative 3. So what we would do first is our exponent, because our parentheses are already done. So we would do our exponent. So negative 3 to the second power we know means negative 3 times negative 3, which gives us 9, which we have here. So now we have 2 times 9 minus 7 minus 3. So now if you look here, we have multiplication, subtraction, and multiplication. So what we did here, we multiplied, because we go from left to right. 2 times 9 gave us 18. Now, if you look over here, we also have multiplication. So we took this sign, which is negative 7 times negative 3, which gives us a positive 21. And our final answer is 39. Now, we come to this next example. Okay, this next example was a little jumbled up early on, but I stretched it out. So we will have evaluate 7 plus 5, in parentheses x minus 4, and that parenthesis is taken to the third power, or cube, for x is 6. So this means that wherever x appears, we're going to replace it with 6. So now we rewrite the problem, except for the 4x equals 6, and then we substitute in 6 for x. Now I would tell you this, even though this is not shown on your paper, I would suggest that you put this 6 in its own parentheses. And the reason being is to show that you substitute in 6 for x. So now we have this expression here, and we look inside the parentheses. This is just 6 minus 4, which gives us 2. And we bring down everything else. So we have 7 plus 5, parenthesis 2, cubed. Now we have addition, multiplication, and the exponent. Because this parentheses here is already done, so we cannot do anything else with it. So we do the exponents next. Parenthesis 2 cubed is the same as parenthesis 2 times parenthesis 2 times parenthesis 2, which will give us positive 8, which we have here. So now we have 7 plus 5 times 8. So now we know we have addition and multiplication. So we do our multiplication. 5 times 8 gives us 40, and 7 plus 40 is 47. Now we come to our next example. It says evaluate 5x plus 3y if x is 2 and y is negative 5. So that means that we would substitute in 2 for x and negative 5 where y appears. So now we rewrite the problem. Then we substitute in 2 for x and negative 5 for y. So now we multiply. Well, first of all, let's look at the parentheses. There's nothing we could do inside these parentheses. There's no exponents available. So we only have multiplication, addition, and multiplication. So we multiply. 5 times 2 is 10. And then we take 3 times negative 5, which is negative 15. 10 plus a negative 15 is negative 5. Now we come to our next example. It says evaluate negative 2x squared plus 5xy minus y cubed if x is 4 and y is negative 2. As you all can see here, we're not provided with the answer, so we have to solve it ourselves. So wherever x appears, we're going to put 4 in its place. And wherever y appears, we will put negative 2 in its place. Okay, so now let's go through and substitute. Well, let's rewrite the problem again. Okay, so we had negative 2x squared plus 5xy minus y cubed. So now we substitute. We had negative 2, x is 4, that's squared, plus 5 times 4, and y is negative 2, minus, and we'll substitute in negative 2 for this y as well, and that'll be cubed. Now our next step, we look at what we have here. First of all, these parentheses, they're already done. So what we're looking for next is the exponents. We have an exponent here and an exponent here. So we know 4 to the second power will give us 16. And negative 2 parentheses to the third power will give us negative 8. Now, if you notice here, we have multiplication, addition, multiplication, subtraction. So we look here, we do our multiplication. Negative 2 times 16 will give us a negative 32. We have positive 5 times 4 is 20, times a negative 2 will give us a minus 40. And then minus a negative 8. So now we will have negative 32 minus 40 minus a negative 8 will give us positive 8. So now we try and combine like terms. Negative 32 minus 40 we know is a negative 72 plus 8. Because since we only have subtraction and addition, we can go from left to right. And then negative 72 plus 8 will give us a negative 64. And this is our final answer. Now we scroll down here to our next example. We have x squared plus 5x minus 3. And we have if x is negative 6. So we know we're going to substitute in negative 6 for x, wherever x appears. So now we'll rewrite the problem. I'm going to write it over here. So we have x squared plus 5x minus 3. Then we will substitute in negative 6 for x. So if you notice here, we cannot do anything else with our parentheses, but we do have an exponent. Negative 6 in parentheses squared will give us 36 plus 5 times negative 6 minus 3. Now we have addition, multiplication, and subtraction. We know we do the multiplication. So we add 36, 5 times negative 6 is negative 30, minus 3. 36 minus 30, because we just had subtraction here, so we go from left to right. 36 minus 30 is 6, minus 3 is just 3. So your final answer here is 3. Now, we have formulas and mathematical models. An equation is formed when an equal sign is placed between two algebraic expressions. A primary purpose of algebra is to provide a compact, symbolic description of the world. We can use formulas for these real-world descriptions. A formula is an equation that uses variables or letters to express a relationship between two or more quantities. The process of finding formulas to describe real-world situations is called mathematical modeling. Formulas, together with the meaning assigned to the variables, are called mathematical models. These formulas model or describe the relationships among the variables. Example, modeling caloric needs. The bar graph shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. Moderately active means a lifestyle that includes physical activity equivalent to walking 1.5 to 3 miles per day at 3 to 4 miles per hour, in addition to the light physical activity associated with typical day-to-day life. Now, the mathematical model W is equal to a negative 66x squared plus 526x plus 1030 describes the number of calories needed per day by women in age group X with moderately active lifestyles. According to the model, how many calories per day are needed by women between the ages of 19 and 30 inclusive with this lifestyle? Now, if we look here at this model, the age range is 19 to 30, and women are pink. So for 19 to 30, these women need 2,100 calories. And that is your final answer, 2,100 calories. Now, if we were just looking at the chart, it would be 2,100 calories. However, we do have a mathematical model. So what we could do is we could substitute in this mathematical model because X represents the group. So this is group 4. So we will substitute in 4 for X. So wherever X appears, we will substitute in 4. Now again, I would suggest that whenever we substitute, we put a parenthesis around the number. Okay, so now we add negative 66x squared plus 526x plus 1030. We put in 4 wherever the x's appear. So we add negative 66 times 4 squared. We know 4 squared is 16. And then we bring down our 526 and then our parenthesis 4 plus 1030. Now we have multiplication, addition, multiplication, and addition. So we know we would do our multiplication. Negative 66 times 16 gave us a negative 1056. 526 times 4 is 2,104. And then that's plus 1030. And then when we add all of these up, this will give us an answer of 2,078, which is approximately the answer that we saw on the graph. The formula indicates that 2,078 calories are needed per day by women in the 19 to 30 age range with moderately active exercise. Now we come to our next example. It says modeling optimum heart rate. The optimum heart rate is the rate that a person should achieve so that the exercise will be most beneficial. 0.6 times the parenthesis 220 minus A is an algebraic expression used to compute the optimal heart rate when A represents the age of the person exercising.